All right, we're going to continue section 1.1, and this time we're going to be looking, or actually being able to graph these parent functions and their transformations. So let's go ahead and take a look at number 5 right here. I look at the equation and automatically there are a few things that stand out. First off, it says f of x is equal to x minus 7. What that tells me, look, there's an x, there's no exponent, um, so that's telling me that this is linear equation. There's no absolute values. So this being right here, just having this x tells me, all right, this is linear. Now don't forget, the other day we talked about a few things. This negative 7 right there is going to be your y-intercept. In front of the x, there's a number. It's not listed in this equation, but there is a 1 there. And remember, that 1 represents your slope, because the equation of a line is y is equal to mx plus b. So now we can go ahead and graph that. The other day I said, all right, we're going to be graphing, to start off with the line, we start with the y-intercept. So, and then make sure in this axis we have intervals of 2. So we'll start right here. I'll plot my first point, or actually it says it's negative 7. So let's go ahead and go down here at negative 7. There's my first point. Okay, so there's your y-intercept, negative 7. Your slope right here is positive 1. So what that should tell you is that this graph is going to go upwards from left to right. I start at this point, I go up 1 to the right 1, up 1 to the right 1. And you should have at least 3 points. Use a ruler, make yourself a straight line, and your graph should look something like that. That right there is the transformation. The parent function, remember, is y is equal to x. So we have right here, there's your y-intercept. We go up 1 to the right 1, up 1 to the right 1, and there's the parent function. So if we were to describe what's happening in the transformation, we can go ahead and say that it has shifted, we can go 7 units down. Okay? So once again, this right here, translation, 7 units down. Take a look at number 6. F of x is equal to negative 9. Or that's the same thing as y is equal to negative 9. That right there should be a constant. Right? If it's just a number, there's no x squared, anything like that, then what we have is a constant, which is a horizontal line. And all the way down here at negative 9, we can go ahead and draw a point. We have intervals of 2 again, and there's our horizontal line. All right, and there you go. This one happens to be a little tricky when we describe the transformation. If you recall, our parent function is up above at f of x is equal to 1. What ends up happening is that students will look at just the equation and think, oh yeah, it went down 9 units, because that's what it says, negative 9. However, it is a little tricky here, because if you think about the parent function, it's up here at positive 1. So in actuality, what happens is that it shifted a total of 10 units down. Okay, so if we were to describe the transformation, 10 units down. And there you go right there. So on a test, it's easy to miss this. I see a lot of students, they miss this problem. They just say it went down 9 units, which is incorrect. Okay. Next up, number 7, we've got ourselves our absolute value. Now, what we're going to show, what I'm going to show you, what I'm going to show you, what I'm going to show you, what I'm going to kind of discuss right here is that, if you think about the parent function, it's up here at positive 1. So in actuality, what happens is that it shifted a total of 10 units down. Okay, so if we were to describe the transformation, 10 units down. And there you go right there. So on a test, it's easy to miss this. I see a lot of students, they miss this problem. They just say it went down 9 units, which is incorrect. Okay. Next up, number 8, we've got ourselves our absolute value. Now, what we're going to show you, what I'm going to kind of discuss right here is that if we look at number 4, okay, what we had before up above, and quadratic equations and absolute value equations are very similar in how their setup and how they react to shifts and transformations. If you look at number 4 and you see right here we have the parentheses, and in number 7 instead of parentheses we have absolute values. The reason why I mentioned that is because if you look in number 4, this plus 4 is telling us that our graph is shifting up 4 units. It's outside of the parentheses. On number 7 right here, this plus 1 is outside of the absolute value. So if this plus 4 told me that it was shifting upwards, on number 7, that plus 1 is telling us that our function is shifting up 1 unit. Inside of the parentheses right here on number 4, this tells us that it's moving either left or right. If it's x minus 1, it's actually going to be moving 1 unit to the right. Remember, I told you what happens is that we take this x minus 1, what you could think about, you set it equals 0 and x is equal to 1. So if inside of the parentheses or the absolute value right here, it was like x minus 1, then it would be shifting to the right 1 unit. If it was x plus 1, then it would be shifting to the left 1 unit. In the function that we actually have right here, all it is the parent function. So think about our parent function. Remember, if f of x is equal to absolute value of x, we start here at 0, 0, and the line is that of slope of 1. Okay? And it is this v-shaped function. That is the parent function right here. Let me go ahead. F of x is equal to absolute value of x. Well, what's happening here is this says it's just plus 1. So what that's going to tell me is that that is going to take our function. It's not going to change, right? It's not going to shrink. It's not going to, what is it? We talk about vertical shrink and vertical stretch. None of that is going to happen. So what I could do right here is start at positive 1 and then think, all right, what's my slope? It's up 1 to the right 1, up 1 to the right 1. Same going the opposite direction in the negative side. And so my function right here, when I graph this, it looks something like that. But for you, you have straight lines because you're using a ruler, right? And so if we're to describe the transformation, it has shifted up 1 unit. And there's our transformation right there. Okay. Let's go ahead and take a look at a few other graphs together. Let's take a look at number 8. We have an exponent to the second power. What that tells me that this is a quadratic function when it's to the second power. We have a negative sign out in front. So that's going to tell me a few things. And in next lesson in 1.2, or actually I think when we get to 1.3, the negative out in front like that tells us we have a reflection. So if you think about our parent function, it starts right here at 0, 0. Over at 1, it goes up 1. At 2, it goes up to 4. And if you're saying, how do I know that? You could always create a table. -1, -2, 0, 1, 2. Plug those in, and then you'll be able to figure out what your function and what your points are. Or you do this enough times and you have that memorized. So, so this right here is a parent function. Y is equal to x squared, or h of x is equal to x squared. Same. So then, if that's the case, if this is a reflection, and what you could do is plug in numbers into your table, right? If you were to plug in numbers, -1 or -2, -1, 0, 1, and 2, and you plug that into here, use your order of operations, you'll be able to figure out what's happening with the function, right? If I, let's say, plug in -2, I've got -2 and I square it, that turns into +4. However, there's that negative sign that's out in front, and that's going to change this back to a negative, and it'll be -4. At -1, we have -1. 0, 0, when you plug this in. Plugging in 1, 1 squared is 1. Add, slap on the negative, -1, and -4. So the vertex right here is still at 0, 0. Let's go ahead and plot that point. At 1, we're at -1. At 2, we're at -4. And there you go. Go ahead and plot that. And remember, a parabola or a quadratic is actually curved. It's not V-shaped like a absolute value function. So make sure you do that. You change that correctly. Okay? And there you go. It has reflected. It has gone downwards. So if we're to describe the transformation, we can go ahead and say there was a reflection across. Now we have to say where the line is. So if it's the x-axis, then we can say reflect across x-axis. But remember, technically it's an equation of a line. The x-axis right here is going to be the same thing as y is equal to 0. Okay, so both of these would be correct if they ask you where does it reflect across. All right, so for number 9 and number 10, you're going to be able to graph those. We'll talk about more specifically on number 10. This right here is the a term. What's going to happen is that every time you plug in a number for x, you're going to have to multiply it by 6. If you think about it, the numbers will get bigger, therefore you'll be stretching the graph. All right, and with number 9, our a term happens to be this 1/8. And then if you recall yesterday, or in 1.1a, if our a term is less than 1, greater than 0, it's actually going to be a vertical shrink, and it'll be wider. Okay, so those are things to consider right there. As we go ahead and move down, let's take a look at number 12 real quick. So we have ourselves a table, and one of the things they ask you for number 12a is what type of function can you use to model the data. Now, what do you do? One of the things that's important to find out or to kind of recognize is, are my intervals for x consistent? Okay, if I look right here, my intervals for x happen to be 1, right? +1, +1, +1, because it goes 1, 2, 3, 4. So that right there is important to make sure that these intervals are consistent. The second thing is, let's see, well, what about for y? Are those intervals consistent? Well, from 12 to 24, that's +12. Add another 12 to 24, that's 36, and add another 12 to 36, and that gets us 48. So this right here has been consistent as well. So what does that tell us? If you were to kind of think about, well, what would the graph look like, right? So if you were to draw like a simple graph, okay, so let's go ahead, and if I were to draw a simple graph right here, it's at 1, and let's say this is 12, okay? At 2, we're at 24. At 3, we're at 36. I'd be safe to say that this right here looks like it's a linear function, okay? It's increased consistently every single interval. right? At every hour, it's always been plus 12, plus 12, plus 12. So that should right here give you an idea that this happens to be a linear function. In Algebra 1, you guys were able to take something like this and come up with the equation of a line. You'll eventually have to do that again this year, and we'll talk about that come later on. Okay, so that right there will conclude section 1.1. You got to make sure you know what happens with those four functions. Okay, because in 1.2, we're going to begin to talk about linear functions and absolute value functions, and more specifically, look at their equations and talk about we have vertical stretch, shrink, uh, transformations, moving up, down, left, or right. Okay, so that right there concludes 1.1.